One of the problems of floods has severe damage to facilities and human life in random places without the knowledge of the people and those responsible for the damage resulting from the solutions used are. Through the satellite, it photographs the places to take its data to send it to the model to train it to predict flood. The satellite light rotates completely in its orbit orientation and focus for the area whose data is to be counted from climate factors and wind intensity. The data comes from the satellites determine the place whose data is to be counted in order to send the data to the form and find out the percentage of flooding in it or the area is safe. A sample of flood areas. The main satellite preparing the data and sending it to the model to train it in flood forecasting. Subset of the satellite image over X location. The satellite records the verified data and sends it to the cloud to send it to ground station. We collect information about the area and train it to determine the incidence of flooding. We define the area, narrow the space, and divide it into topography, land cover, and buildings. We generate flooded areas as well as impacted people and infrastructure. We warn residents by sending a message through our application to take precautionary measures. Welcome to our demonstration of how we can predict rainfall using one advanced sensor and artificial intelligence. Our weather monitoring system uses a single sensor that measures temperature, humidity, wind speed, wind direction, and rainfall. Our AI algorithms can analyze changes in weather patterns and identify the formation of a storm, indicating when rainfall is likely to occur. This is especially useful for anyone planning outdoor activities. Our AI model predicts rainfall by analyzing data from the one sensor. When there are changes in temperature, humidity, wind speed, and wind direction, our system generates a warning predicting the onset of rainfall. Rainfall. Our advanced weather monitoring system uses one sensor and AI technology to predict rainfall by analyzing real-time data. This information is crucial for many industries, and our AI model ensures accurate predictions, helping people plan for the weather. Many people suffer from water leakage problems, especially water leaks in underground pipes and the difficulty of knowing the time of leakage and determining the form of leakage. And with the great development in the field of the Internet of Things and artificial intelligence, we used a group of sensors to predict the occurrence of leakage and its location, such as the accelerometer sensor, which predicts the occurrence of leakage based on the speed of water in the pipes, and thus the places of leakage are identified, which helps people to take the necessary measures early. These devices are connected to a network, and this network is connected to a mobile app in order to send notifications to users of a leak. The artificial intelligence model takes data from the sensor and analyzes it. In the event of a leakage, a notification is sent to the user through the mobile application informing him of the occurrence of a leak. Percent of the global fresh water supply has diminished due to drought and climate change. According to the World Health Organization, more than 2 billion people lack access to safe drinking water and 3.6 million people die annually from water-related diseases. The process of determining and controlling water quality is an important matter, as that process depended on the human element, as the person used to take a sample of water and from it he determined the elements and components of the water, including. This was expensive, ineffective, and dangerous. One of the problems facing the water treatment process: first, the difficulty in determining the amount and quantity of chemical oxygen. Secondly, the difficulty in determining the sufficient and appropriate amount of energy consumption and processing, which leads to high costs. For water quality and its contents, there are components that are used in the smart device. On the left side is a pH sensor, which can be used to detect the acidity or alkalinity of the water. On the right side is the turbidity sensor, which detects the cloudiness of the water. Most importantly is the Arduino Mega, which acts as the brain of this device. It controls all other components on these smart devices. It controls all other components on these smart devices for water treatment process. There are also many sensors used too, such as temperature sensor and pressure and humidity, ammonia and nitrogen, water in order to determine a set of variables such as measuring pH and others. Below, pH is a measure of the concentration of hydrogen ions in a fluid. The most common method for online pH measurement is potentiometric glass pH sensors. Let's now concentrate on the amperometric measuring principle. An amperometric sensor usually consists of a gold cathode, also called a working electrode, and a silver chloride electrode that forms the anode. A DC voltage is applied development in the field of technology, especially artificial intelligence. We have linked IoT devices with artificial intelligence in order to determine water quality. This is all the required data, and with the great development in the field of technology, especially artificial intelligence, we have linked IoT devices with artificial intelligence to carry out the water treatment process with the highest efficiency by using pre-trained deep learning models to determine the amount of chemical oxygen required, the biological oxygen required for the treatment process, based on the extent of water quality. The sufficient amount of energy required for the treatment process can be determined, which leads to saving electricity costs and rationalizing consumption. In order to achieve sustainability, these sensors are linked to a network and to the cloud. And all of this is linked to a website, as well as to a mobile phone program, which helps reduce the cost and time in the water quality determination process. Using this smart application, the water treatment process can be controlled. Find out the desired output, the amount of energy required for processing, and the amount of chemical oxygen. Finally, the amount of biological oxygen. This smart solution will save you time and money. Have you ever wondered how to measure your home's water usage? Traditionally, water meters were read manually by individuals who visited homes and wrote down the readings once every 4 weeks. This process can be time-consuming, inefficient, and prone to errors. We all consume high amounts of water, and many don't even notice it. So we thought of smart water meters. We all consume high amounts of water, and many don't even notice it, where they put a sensor connected to the meter, which takes an image of the meter and sends it to the AI model for analysis and determining the meter reading once every 30 minutes. It then displays the result on a mobile app. Users can easily track their water usage and can even receive alerts if they exceed their set limits. Water is often used in factories in large quantities for various industrial processes. However, many plants still use primary water meters that require manual readings. This can be a time-consuming and inefficient process, as workers have to physically visit each meter and manually record readings. In addition, primitive water meters may sometimes malfunction, resulting in inaccurate readings and a potential waste of water. We provide a solution to these problems by automating the water meter reading process. This data can then be monitored and analyzed by technicians using the mobile app. With this software, plant managers can track their water usage and identify any deficiencies or areas where water is being wasted. They can also set alert to notify them if water usage exceeds a certain limit or if there is a sudden increase in water usage.